In this part of chemistry, we are going to talk about bonds. What are bonds? What do they mean? What types of bonds are there? What's the benefits of bonds in our real life? How things we see them without bonds and with bonds as well. Okay, for example, now if we have a pen in our hand and we want to break this pen, some pens we're going to break them easily, while other ones we're going to find them that it's harder a little bit to break them. Okay, if you take another thing like a bar of steel and you want to break it, also you'll have a difficulty to break that one. But what about if it is wood? It's going to be easier. What about other things? So things now, when you break them, how hard or how easy is it for you to break it? This is related to how strong the bonds between the molecules inside it is. So this is now the idea of bonds and why things are combined together in one whole body. For example, now why do we see the plastic? You take, for example, now any container of plastic around you, or a chair, or a plastic, or any object. When you see it as a whole object, what makes this object a complete object? Why it's not looked like pieces? That means there is attraction between the molecules inside this object. So that's why we see it as whole body. So these ones as a result of bonds. Okay, what are bonds? So bonds, we can say it is attraction. It's just the force of attraction. And this force of attraction, it can be between molecules, it can be inside the molecule. How? For example, here, if we have sodium, Na, plus Cl, which is chlorine, it will give us, as we know, NaCl. Sodium is an element and chlorine is an element. So these ones are reactants and they'll produce what? Product, which is NaCl. And all of us, we know it as if it's salt or table salt that we use it with our food. So this one now, NaCl, it is a compound of mainly two elements, which is sodium and chlorine. Okay, what links sodium and chlorine to be together as NaCl? Okay, Na, sodium, as we know, it has electrons around it. And chlorine, it has electrons around it. And one electron of sodium will go to chlorine. So chlorine, when it receives an electron, it's going to be negative. It's going to be what? Negative ion, which is anion. While the sodium will be changed into what? Positive, because it loses one electron. It loses one electron, that means now the positive charge, which of protons, becomes more. Anyway, these ones now, this one is a positive part and this one is a negative part. What will happen between them? Attraction. So this attraction now, it is the main attraction between the molecule or inside the molecule of NaCl. That means these ones now, you're going to see them, each molecule of salt is combined together between the sodium ion and the chlorine. So in this case, this attraction is a bond. And what type of bond? As you see, this bond now is inside each molecule between the atoms mainly. And it's inside the molecule, so this one, we call it intramolecular force. So we have intra, keep that in mind, and we have what? Intermolecular force. Intra means inside the molecule. That means between the components of the molecule itself, this attraction now is, we call it what? Intra. But now this one is one ion only. This one is just one ion of sodium chloride, just one ion. One molecule, one molecule. And this one now is the attraction between inside the one molecule. But one piece of salt, it has billions of molecules of NaCl. Okay, now, what combines this molecule to another molecule? NaCl. This now is another molecule. So inside the molecule, the force of attraction that is inside the molecule, we call it intramolecular force. Now, this molecule and another molecule, what is the attraction between them now? Between the molecules themselves, this attraction, we call it what? Intermolecular force. So you have two types of forces or two types of bonds. One of them is intramolecular force, and it is exactly inside the molecule. And one of them is intermolecular force, and it is the attraction between the molecules and other molecules. And I hope that is clear now. What's the difference between intra and inter? Okay, now, for each part now, intra and inter, we have examples. So here now, here we have intra, and here we have what? Inter. For each part now, we have examples. So here we have ionic number 1, which is ionic bond. Ionic bond is exactly the same like Na and Cl. As you said, it will give us NaCl. And in this case, the sodium will lose, as we said, electrons, and the chlorine will gain electrons. So when there is losing and gaining electrons of the atoms, what will happen is ionic bond. Plus, this one is metal, and this one is non-metal. This one is non-metal. So that means the attraction inside the molecule of a metal and non-metal atoms, that is a result of losing and gaining electrons, is called ionic bond, and it is the strongest intramolecular force. So we are talking about intra. That means we are talking about the bond that is inside the molecule. For example, now you have a family. You and your brother and your father. Here now the attraction, or what makes this family together, intra force. That means attraction inside the family. But now you have a family and you have like your cousin's family. So that means what is the attraction now between your family, which is your father and brothers, and the other family? That ones we call it what? Intermolecular bonds. So it is inside the family or with other families. So inside here the molecule, this is intra, and inter is between the molecules. So ionic is when there is a metal and non-metal, they reacted together and they produced a compound, or they produced a product. In this case, the bond between its components will be what? Ionic. Okay, what's the second one? The second one is covalent bond. What is covalent bond? Covalent bond, it's a result of sharing electrons, not losing and gaining electrons. How? For example, now we have hydrogen and we have oxygen. And as we know, on the periodic table, hydrogen is element number 1 on the periodic table. That means it has only 1 electron on its first shell. So it has only 1 electron. And now oxygen, as we know, it has 2 shells. And on the first shell, it has 2 electrons. And on the second shell, it has 1, 2, 3, 4, 5, 6 electrons. Now, in order for these atoms, whether is it hydrogen or oxygen or other elements, they need to reach the octet state. That means they need to reach 8 electrons in the second level or in the third. So in this case now, oxygen is not stable because it has 6 electrons in the second shell. So it needs either to gain 2 electrons or to share electrons. So or to share electrons to feel that it has 8 electrons. Hydrogen now as well, it has 1 electron. So it needs to have 2 to be stable or to share an electron. Okay, if we make now 2 atoms of hydrogen, this is also another atom of hydrogen, and it has also what? 1 electron here. Now we have 2 atoms of hydrogen and 1 atom what? Of oxygen. What will happen now? Hydrogen will not lose electrons and oxygen will not lose, and none of them will lose, none of them will gain, because both of them, as we see here, are non-metals. So what will happen then? They'll share electrons. So here now, 1 electron of hydrogen atom and 1 hydrogen of oxygen atom, they'll be shared. They'll be shared, that means they'll move these 2 electrons, this pair of electron will move like if it is shared for the oxygen and for the hydrogen. That means the oxygen will feel that it has this pair of electron, and also the hydrogen will feel like if it has this pair of electron. And also here, these 2 electrons will be shared. So now what will happen? If we go to see the oxygen part, we're going to see that oxygen now will feel like if it has 8 electrons, 6 electrons that already has it, and other 2 electrons that were shared by the other atoms of hydrogen. And now this atom of hydrogen also, it will feel like if it has 2 electrons, and this one now it will feel like if it has what? 2 electrons. So here now, this one here, it is called what? A bond. And here is what? Is a bond. So that means they made, oxygen makes 2 bonds with 2 atoms of hydrogen to feel stable. So in this case now, what this compound will become what? H2O. That means 2 hydrogen atoms and 1 oxygen atom. Now the attraction between the oxygen and the hydrogen, that is as a result of sharing these 2 pairs of electrons, is called covalent bond. So what is covalent bond? Covalent bond usually it is between non-metals and non-metals. Here hydrogen is non-metal and oxygen is non-metal, and it's at a force of attraction between these ions as a result of sharing electrons. So now we understand ionic and you understand what? Covalent. What is the third one? Third one is metallic bond. Is metallic bond. Okay, what is metallic bond now? Metallic bond, from its words, it's related to metals. So for example, now when you see a bar of copper or aluminum, what makes this one as one object? It is metallic bond. So how metallic bond? Here now, if we have here this part of aluminum, here we have atoms as we know. And around these atoms, as we know, there are electrons. So these electrons now, for metals, these electrons can move freely. That means they are not that strictly attracted to their nuclei. So that means they can move. When they move now in this part, what will happen now? Just so you see 1 electron. For example, this electron now is here. When it moves to here now, its atom here, mainly, like if it loses 1 electron, so it will be positive charge. And here this is negative. So the attraction now between these electrons that they are moving here freely and the positive nuclei, this attraction now is called metallic bond. So that means you have too many atoms of metals, and around them there'll be many electrons. These electrons, they'll move. When they move, there'll be attraction between them and the nuclei there. In general, not just 1 electron and 1 atom. No, in general, 1 nuclei. So it's attraction between these, in general, electrons and their what? And their atoms. This attraction now is called metallic bond, and it is in metals. And we call these electrons delocalized electrons. And for metals, what makes them good conductors is these electrons, since they are freely moving. So that means if they are connected by voltage, these electrons will be moving. So that means they'll be good conductors. So we have now for intra, and when we say intra, we said that means you are talking about what is inside the molecule. Inside the molecule, we'll have ionic, we have ionic bond, and we have covalent bond, and we have metallic bond. Okay, now we'll go to the other side here now, which is intermolecular force. Okay, this intermolecular bond or force, it's exactly between the molecules. It's between the molecules. How does that happen? We're going to take water here to explain more. Okay, so here now we have 3 bonds as well. We have number 1, that is called London dispersion force. London dispersion force. And number 2, we have it dipole-dipole bond. And number 3, it is what? So dipole-dipole bond. Number 3, it is called what? Hydrogen bond. It is called hydrogen bond. Okay, London dispersion force. It's the weakest one of intramolecular force. And again, this one is between the molecules. Okay, we're going to take now example. If we have now like fluorine, the atom of fluorine, we have it, it has what? Electrons. This is one atom. If we have another atom of fluorine and another atom here, as we see, so we have like many fluorine atoms. These atoms, they'll have attraction between themselves, as atoms, as many atoms. So you're not talking about just one molecule. We're talking about many atoms here. That means the attraction between them here in this case. These electrons, they'll move around the fluorine. And due to their movement, they will not be stable. That means they will not move in an unorganized way. They'll move randomly. And when they move randomly, at 1 second, at one period of time, you're going to see more of the electrons are on this side and less are on the left side. So in this case now, this side, as long as it has more electrons, we can classify it as negative. And this side that has less number of electrons, we can classify it as what? As positive. And now between these two sides, you'll have attraction between the positive side and the negative side. And this attraction is called London dispersion force. But it is temporary. That means just it's as a result of the movement of electrons where one side will have more electrons. But with time, just it is for short of time, then the electrons will change their movement. So that means you'll have the other part positive, other part negative, or they're going to be neutral again, then they get positive. So this attraction is very weak, and it's just related to the movement of the electrons. And mainly CH4, which is methane, oxygen, okay, these ones mainly what links them together, like means what links now methane, CH4, as a molecule with another molecule of CH4, with another molecule of CH4. What links it together? This one is what? London dispersion force. And if we have here, this one is a molecule. What links this molecule with other molecule? With other molecule is London dispersion force. Okay, if we go now to the next one, and we're gonna take examples. We're gonna take more examples to understand it deeply. What's the relation between intra and inter? Okay, this one now, which is dipole-dipole bond, we're gonna explain it with water. So for example, now if we have water, as we said, this one hydrogen, and here hydrogen, and here oxygen. And we said around hydrogen, around oxygen here, atoms, and around this one atoms, and they'll have bond here. There is what? Bond, as we explained. Bond, that is what? Of a pair of electrons. Okay, now, as we said, what is the bond that links hydrogen to oxygen? Inside the molecule, we said it is what? It is covalent bond. This is inside the molecule itself, inside the H2O. Okay, but now if I have another H2O, if I have another what? H2O, that means another molecule. Here we said bond here, and this one you call it what? Covalent bond. Okay, this one now is molecule, and this one is molecule. And inside the molecule, there is intramolecular force, which is covalent bond between the hydrogen and the oxygen. But now, what links what links this molecule with this molecule? That means there is now attraction between the two molecules themselves, and this one is no longer intramolecular force, is no longer covalent. No, here it is intermolecular force because it is between the molecules themselves, not inside each molecule. Okay, what links this one here and this one? Is there any attraction? We're gonna see what. As we know, here a pair of electrons is shared between hydrogen and oxygen. But now this pair, pay attention to this pair of electrons, when it is shared between hydrogen and oxygen, will this pair will stay exactly in the middle, as a distance in the middle between hydrogen and oxygen, or it will be closer to oxygen, or it will be closer to hydrogen? Where this pair be located? Closer to oxygen or hydrogen, or in the middle? In this case, if two electrons are shared between two atoms, this pair of electrons will be closer always to the atom that is or that has greater electronegativity. Greater electronegativity. And as we know, when we go from left of the periodic table to the right, and we're going to show that, if you go from the left of the periodic table to the right, electronegativity will increase. So here now, oxygen has higher electronegativity than hydrogen. So that means oxygen will have higher ability to attract this pair of electron to be closer to the oxygen, not closer to what? To the hydrogen. So this pair now of electrons, as you see, we're going to show how is it. So they're going to be closer to what? They're going to be closer to oxygen. How? So that means this pair now of two electrons, they're going to be closer to what? To oxygen. And here they're going to be closer to what? To oxygen, and a little bit far away of what? Of hydrogen. As a result of this attraction, what will happen? That means oxygen part that means the electrons are closer to the oxygen. That means it's going to be like if the oxygen is gained or has more electrons towards itself. What will happen as a result of that? As a result of that, we will classify this part as partially negative side. And this part now, we're going to classify it as partially what? Positive side. So that means in general, we understand that the side in chemistry that has more electrons, that means it's going to be negative. And the side that loses electrons will be positive. Why it will be positive? Because when it loses electrons, that means in this case, number of protons inside it will be greater than electrons. So that means the positive charge is greater than the negative charge. So that means in this case, it's classified positive. So here is the same now. So this part now, as you see, it's going to be classified partially as what? As negative. And this part will be partially as what? As negative and positive. And here is what? Also it's going to be what? Positive. Now, what will happen? What will happen as a result of that? What will happen is really attraction between this negative charge and this positive charge. You see, there'll be attraction now between the side of oxygen that is negative and the side of hydrogen of another molecule. So that means this attraction now, we call it dipole-dipole bond. Dipole-dipole what? Bond. Why we call it dipole? Because di means two poles. Because now if we see this molecule now, it has two poles. One pole is positive and one pole is negative. Here is the same. As you see, we have one pole that is positive and one pole that is negative. So this part has dipoles, two poles, and this part has dipoles. That means two poles, one positive, one negative. And the attraction between the dipole and the dipole here, we call it what? Dipole-dipole bond. So that means this attraction is between molecule and another molecule. Now these two molecules. Okay, what about if we have here another molecule? Also you'll have attraction, another molecule, attraction, another molecule, attraction. So that means between the molecules now, there'll be attraction, and you call it dipole-dipole bond. Okay, now what's the difference between dipole-dipole bond and hydrogen bond? And I need you to memorize that. Dipole-dipole bond, it's attraction between a positive part or pole of one molecule and another part or negative pole of another molecule. This attraction is dipole-dipole bond. But if this dipole-dipole bond, if hydrogen is inside it, is there hydrogen here? Yes, there is hydrogen. If hydrogen is there and the hydrogen is combined with higher electronegativity atoms like oxygen or nitrogen or fluorine, keep that in mind. So if hydrogen now is bonded with oxygen or with nitrogen or with fluorine, in this case, instead of calling this one dipole-dipole bond, and it's right if you call it dipole-dipole bond, but also you can call it what? Hydrogen bond. So hydrogen bond is type of dipole-dipole bond. In general, it's the same like dipole-dipole bond, but if the elements inside it is hydrogen is there, if hydrogen is there, instead of calling it dipole-dipole bond, we can call it what? Hydrogen bond, but it's still dipole-dipole bond. And this hydrogen has to be with oxygen, fluorine, or nitrogen. Okay, now what will be the result now of this attraction between the molecules of water? What will be the result of this attraction? The result of the attraction will be, why do we see water liquid as one part, as one object? So when you see now the water in a bottle or in a container, you're going to see it like one whole object. That means the particles, the molecules of water, they are attracted to themselves. Okay, what links them together to see that it is water? This type of bond, which is what? Intermolecular bond, which is dipole-dipole, or we call it hydrogen bond. This one now will attract too many molecules of water together. Like they're going to be like a chain together. All of them, they attract each other. In this case, they'll be close to each other. The molecules will be close to each other. So when the molecules are close to each other, you're going to see the whole object as water. But I'm going to tell you something. What about if we heat water? If we heat water now, that means you are heating the molecules, right? When we heat these molecules, the bond between the molecules here will be broken. When this intermolecular force between these molecules is broken, what will happen? That means molecules, they'll be separated alone. So these molecules, they are very light, so they'll escape to the air as gas. So you will not be able then to see water as a whole part, as liquid. That means now you will not see it. It will evaporate as gas up, so no water, you will not see it. So what is the reason behind seeing water in its liquid state? Is the attraction between the molecules. When there is attraction, that means there'll be a group of billions of molecules, so you see them water. Other cases, if they are evaporated or this bond between the molecules is weak, that means they'll be evaporated out. That means they'll be turned into be what? Gases. And that's the result behind why some elements or molecules are gases while other ones are liquids, while other ones are solids. So that means it's the result of intermolecular force. If it is strong, they're going to be solid. If it is a little bit weak, it's going to be liquid. If they are very weak, they're going to be what? Gas. So fluorine is gas, chlorine is gas, and other molecules, we have them what? As gases, because the attraction between the molecules is very weak. So if you strengthen that attraction, they're going to be changed into liquid. They're going to be changed into solids in general. And on the other side, if you weaken this attraction, they're going to be from liquids to gas or from solids to liquid to gases. So you understand now the type of attraction. Okay, we're going to take now, what's the relationship now between inside and outside? And you're going to explain it just with oxygen here. If we have oxygen atom, and around it, as we know, for the first shell, we have 2 electrons. And for the second shell, we have what? How many? 6 electrons. This one is a basic here. So here now, 2 bonds, and there you have what? 6 bonds. This is now 1 oxygen atom. one oxygen atom. If we have another oxygen atom, it will have the same thing. Here is 2 and here is 6 electrons. Now, this oxygen here, there are two atoms. In general, in reactions, if you remember, when usually we write O, we write it O2. When you write H, we write it H2. When you write F, we write it F2. In general, why do we write them in reactions like 2, 2, 2? While, for example, aluminum, we write it aluminum, we didn't write 2. Lithium, we write it Li. Fe, we write it Fe. We didn't write 2, 2, 2. Why? Because oxygen now, when we find oxygen in our real life, we find oxygen like 2 atoms, like 1 molecule. So you find them in nature like 2, like a pair of 2 atoms. Okay, why? Why? This is now what we are going to explain. For example, here oxygen, as we see, it has in the first shell 2 electrons, and in the second shell it has 6 electrons. Now, this atom now alone, it's not stable because it needs more 2 electrons to reach 8 on the second shell to be stable. Okay, and this one is the same. It needs 2 electrons in order to reach what? Stable state, which is octet state. So in this case, what they do, these 2 electrons, these 2 atoms now, these 2 electrons, they'll be shared, and these 2 electrons, they'll be shared. Now, each atom of oxygen will feel like if it has how many? 8 electrons, because 2 electrons of the other atom is shared with it. So that means it will feel like if it has what? 8 electrons. So a little bit it's gonna be what? Stable. So that means we're gonna see in nature oxygen usually like what? Like O2, 2 atoms of hydrogen, 2 atoms of hydrogen, 2 atoms of oxygen. So in this case now, what is, just as a question, what type of bond is this one? Is it intramolecular or inter? Think of it. It's intramolecular force. Why? Because it is inside the molecule. This one now is 1 molecule. O2 is 1 molecule. And the force inside it between the 2 atoms of oxygen. So in this case, it is intra. And what type of bond? We said intra, we have covalent, we have ionic, and we have metallic. So what bond is this one here? It is intra and it is covalent bond because it is sharing of electrons of non-metal oxygen and non-metal oxygen. Okay, so inside it, this one here, we said it is what? Covalent bond, and it is what? Intra, inside. Okay, now if we make another molecule here of oxygen, here is. This one now is another molecule of what? Of O2. Okay, now will there be attraction between this molecule and this molecule? These electrons, as we said in general, that are inside this molecule, they'll rotate, they'll move. They'll what? They'll move. They will not be fixed in their places, they'll move in general. When they move, that means at one time or at 1 second or 2 seconds at specific time, more electrons, for example, will be on this part and less electrons will be in this part. So that means this whole molecule, it has 1 pole positive and 1 pole what? Negative, just for a period of time. And here will be the opposite or the same. It will be one side more electrons, one side less, as a result of the movement of electrons. So this now, that is temporary movement or temporary randomness of electrons, where one part of the molecule will have more electrons and one part will have less. So in this case, that molecule will have 2 poles, positive and negative, and that one will have positive and negative. So this attraction now between this molecule and this molecule will be what? Called London dispersion force. So you explain now for oxygen, what is the attraction between its elements in a molecule, and what is the attraction between one molecule and another molecule? Okay, is this one now, which is with the attraction or the force that attracts this molecule and this molecule, is it strong? It's not strong. Why? Because if it was strong enough, we're going to see the oxygen as liquid. but we don't see it as liquid, it's gas. And when it is gas, that means each molecule is alone. Each molecule is alone because the attraction is very weak. And if it happens, it's temporary. Just for a short of time, you'll have attraction of 2 electrons. That means 2 molecules here, they are in the air. You see these ones, molecules of oxygen. So at one specific time, you're going to see attraction here between this part and this part. But this attraction will be changed with another part. So that means it's just as a result of, and it's very weak. We didn't mean it. Okay, now, what do we need just to know more? We said the oxygen and the oxygen, they'll make 2 bonds here. They'll share here what? 2 electrons. And we said for the oxygen, and this is now for the oxygen and the oxygen. And for the oxygen and hydrogen, we said it will be shared here, and another one will be shared 2 electrons as here. So with oxygen, usually it makes 2 bonds. 2 bonds, either with oxygen with another oxygen or oxygen with hydrogen, 2 hydrogens. So now, in this case now, these 2 or these electrons that are shared, where they'll be located? They'll be closer to this oxygen or to this oxygen. Since oxygen and oxygen, they have the same electronegativity. So that means these ones will be in the middle. Okay, what about these ones now? We said these ones now, since the oxygen has higher electronegativity, so it will attract these ones closer to it. And this one now as well, it will be attracted to what? To this oxygen. So that means this part, we said it's going to be partially what? Negative, and here partially what? Positive, right? So in this case now, in this case, the 2 electrons we said they're going to be closer to oxygen. The 2 electrons here will be closer to oxygen, but here they'll be exactly in the middle. In the middle, that means there is no higher electronegativity pole will attract them, since both atoms are oxygen. So we call this one now, this one is covalent bond, and this one is covalent bond. Both of them covalent because sharing of electrons, and inside, not outside, inside the molecule. So this one here, we call it polar covalent bond. While this one just, we call it non-polar. Non-polar what? Covalent bond. So now, covalent bond is intramolecular force, and it is inside the molecule. And it can be classified as polar or non-polar. Polar covalent bond, it is the bond where it is between 2 different atoms in electronegativity. So in this case, it will produce poles. That means it will make 1 pole negative, 1 pole positive. So in this case, we call it what? Polar covalent bond. And this one here, we call it here what? Non-polar covalent bond. So we understand now in general, what's the difference between intramolecular forces and intermolecular forces, and you understand why we see things in our lives as whole objects, why we see the screen of our mobiles like a whole object, and why when a screen of a mobile you can break it while the other one you cannot break it, why one is stronger than the other. Because the attraction of these bonds between the molecules is stronger than the other one. So that means it's responsible for making things stronger or weaker. And it's responsible for objects for being either solid or liquid or gases. Okay, now we're going to see the periodic table, but with numbers of electronegativity. Which element has higher or less? We're going to see it now. So this one now is the periodic table, as we know, and it has now numbers, and these numbers are electronegativity values. Electronegativity what? Values. So if you see here, lithium, here, it's going to be 0.98. Then if you continue to beryllium, it's going to be 1.57. Then if you go here, as you see, as you go from left to right, on the same period, you're going to see that electronegativity increases. Electronegativity what? Increases. So for oxygen, as you see, the electronegativity is 3.44, right? And with lithium here, it's just 0.98. So electronegativity from one element to another element, they're going to be different. So when we explained that oxygen and hydrogen, oxygen here, we said, and hydrogen here, when they share a pair of electrons, this pair now will be attracted to the highest electronegativity element, which is the oxygen. It's 3.44, but here hydrogen is just what? 2.2. So we understand now that each element, it has electronegativity. And what is electronegativity? Electronegativity, it means how strong that element to take the electron. How? For example, now I have fluorine here and I have chlorine, as you see. And each of them, they need just one electron to be stable. So they are active elements, halogens, but active. Fluorine and chlorine, they are very active. So each of them needs one electron. Okay, if I have here fluorine and I have here chlorine, and I have one electron is moving here, which one will have a higher ability to attract this electron, to take this electron? Will the chlorine take it or the fluorine will take it? So the one that has higher electronegativity will take that electron. So in this case, as you see, fluorine is 3.98 while chlorine is 3.16. So that means fluorine will take that electron. So as you see here now from the periodic table, you're going to see that fluorine has the highest electronegativity of all the periodic table. While, which one is this one? As you see, francium is the least. So that means if you go to the right, what will happen now? Electronegativity will what? Will increase. But if you go down the periodic table, it will what? It will decrease. It will decrease. So that means francium will be the least and fluorine will be the highest electronegativity. Okay, now we understand also that there is polar and non-polar covalent bond, and we understand the difference between them. So when we write O2 or H2 or F2, if we are talking about what type of bond inside it, it is covalent bond. But what type of covalent? Non-polar. So that means the fluorine will be exactly like this, you see, and one bond here. And hydrogen will be exactly like this, and one bond between them. And oxygen will be like this and two bonds between them. So that means this type of bond now, as you see between the atoms inside the same molecule, are called what? Non-polar covalent, because the two parts of the bond have the same electronegativity. So this one is what? Non-polar covalent bond. Okay, now I'm going to take something. I'm going to talk about something. If we are talking about fluorine and chlorine and nitrogen, and as we know, and when we write them on reactions, we write them what? We write them like F2 and O2 and N2. That means we found them as molecules of two. Okay, now which one now? All of them have covalent bond between them. So that means this is now between the fluorine atom and another fluorine atom in the same molecule. Here it has two. So that means there is covalent bond inside it, and this one covalent bond inside it, and this one covalent bond inside it. Okay, which one will have the greatest covalent bond? That means the strongest bond between them. Is it fluorine or oxygen or nitrogen? Think of it. Okay, let's now explain how. This one now is fluorine, and it has two atoms. And here now the oxygen will have what? Two atoms. And the nitrogen will be what? Two atoms as a molecule. Now, as we know, fluorine, its valence here, how the electrons, it has, as you see here, 9 electrons. So 2 here in the first level and 7 here in the second level. So that means it needs only 1 electron to be stable. So fluorine, it needs only 1 electron. While oxygen now, it has here is 2, and it has here what? 6. So it needs 2 electrons to be stable. While nitrogen here, it has 2 on the first shell and 5 on the second shell. So it needs 3 electrons to be stable. So you see? So that means on this case, okay, if we continue for carbon, it needs 4 electrons to be stable. So that means in this case, fluorine, when it makes bonds, it will share 1 electron because it needs 1 electron. So it will make 1 bond only. So one electron from this atom and one electron from this atom, they'll be shared. So in this case, each atom of fluorine, if it feels like it has what? 8. Done. So that means it shares just by one electron to feel like if it has one extra electron, and that's enough. Okay, what about oxygen? Oxygen, it needs to share 2. Well, here 2 and here is 2, so that means they'll make what? 2 bonds. 2 bonds. So that means now each oxygen, as we said, this oxygen has 6, so 2, here is 2 and here is 2. So it has what? So 6 electrons around each atom, they'll be shared. Now each atom of oxygen, as you see, it will feel like, for example, this one, it will feel like if it has what? 8 electrons, so it feels it's stable. And this one will feel like if it has what? 8 electrons, so it will be stable. That's why when they make bonds, they'll make 2 bonds. That means they share 2. Okay, what about nitrogen? It needs 3, so it will make what? 3 bonds. It will make what? 3 bonds. So in this case, 1 bond, 1 bond, 1 bond. So that means inside the fluorine molecule is covalent bond. Inside the oxygen is covalent bond. Inside the nitrogen molecule is covalent bond. But which one is the strongest? The more number of bonds, the strongest it is. So that means nitrogen has the highest covalent bond inside its molecules, more than compared to oxygen and fluorine. So if we order them now, nitrogen will be the highest, then oxygen, then fluorine. So now, if we compare the strongest, if we compare the longest, look, the more number of bonds, the shorter the bond will be, the strongest it's gonna be. So nitrogen will be the shortest bond and the strongest. Fluorine will be the longest bond and the weakest. So you understand now how covalent bonds are. And these types of bonds, we said they are non-polar covalent bond because it's between 2 equal electronegativity parts. Okay, if we compare now on the other side, if we go to this part, which is fluorine, chlorine, bromine. The fluorine F2 as what? As molecule, then bromine, then iodine. Inside these molecules, inside them, what is inside them? We said covalent bond. Okay, now, what links this fluorine with another fluorine? That means we need what? And we need intermolecular force. We need what? We need intermolecular force that links each molecule with another molecule, right? Cl2 here, and here Br2. So now each molecule, what links this molecule with another molecule? We said it's gonna be inter, not intra. Intra is inside the molecule itself, but between them, it's gonna be intermolecular force. Now this type of attraction, what type of intermolecular force it's gonna be? Is it dipole-dipole? No, because there is no dipole-dipole here. It's non-covalent, so that means inside it no covalent bond. If inside the molecule is non-covalent bond, that means as a result it will not be polar or dipole-dipole bond outside. If inside is no poles, that means outside will not be attraction like poles. Okay, we understand that. So that means what type of attraction here? We have 3 types of attraction we said between the molecules, either dispersion force or dipole-dipole bond or hydrogen bond. Here there is no dipole, so that means it's not hydrogen bond, it's not dipole-dipole bond. So what it is dispersion, London dispersion force. So that means the attraction now between the molecules of fluorine or chlorine and iodine is London dispersion force. And London dispersion force, as we explained it, it's related to the movement of electrons. So when the electrons are moving here, when they move, some parts of the molecules or of that object will have higher electrons, so to be classified as negative, and one part will be what? Negative. So here now, this movement, as we see, this movement now for each element, molecules, for many, I'm talking about many molecules of that element, the attraction will be between them related to the movement of electrons. Okay, which one has higher electrons? If we classify them, as you see, you're going to see that fluorine has 9 electrons, chlorine 17, and here is 9 electrons, and bromine, as you see, it's going to be 35, and here iodine is going to be what? 53. So that means if we go down this group, we're going to see more electrons it has. If more electrons, that means the movement will be higher. The possibility of making positive and negative poles will be higher. So that means if you go down now, which one will be higher in London dispersion force? It's going to be iodine, because more electrons are moving. So higher ability of making what? Poles, negative and positive. So in this case now, Shabab, iodine will be the strongest one for dispersion force, while fluorine will be what? The least. Okay, what will be the result of that? What will be the result? So fluorine, it's very weak. It's very weak because less number of what? Of electrons. So that means fluorine now will be gas because it's weak between. Chlorine is also like 9 and 17. It's close to each other. So chlorine in general also it is what? Gas, because the attraction is still weak. But this one is 35 for bromine. Bromine has higher number of electrons, so the attraction will be greater. The movement will have greater chances to make poles. So that means bromine, we see it liquid. And iodine has more. It's going to be solid. And that's why, as I said, why we see things, solid, liquid, gas, it's related to attraction between the molecules, not inside, between the molecules, because we need to see too many molecules combined together. We need to see them to judge that this one is liquid, or this one is solid, or this one is what? Gas. So here for electrons, as we said, dispersion force, the more the number of electrons, the more or the greater the dispersion force will be. So the greater the dispersion force, that means the attraction will be greater. In this case, we see, or as a result, we see why fluorine is gas, chlorine is gas, and bromine is liquid, and iodine is solid. Because when we go down, there is stronger attraction between the molecules. Okay, last part, we explain it today, is related to the difference between the elements when they make compounds. Okay, for example, now we studied when sodium, for example, with chlorine, when they make NaCl, which is stable salt. Here now, if we see sodium here, what is its electronegativity? It's 0.93. Okay, what about chlorine here? It's 3.16. So in this case, what's the difference between them? What's the difference between chlorine and sodium electronegativity? What's the difference? That means you can round it like about 2.20. The difference is going to be around 2.20. If the difference now is greater than 1.7, if the difference between this electronegativity and this electronegativity is greater than 1.7, you say always that this bond is ionic. Is what? Ionic. And it is the strongest one. The strongest intramolecular force. We are talking about now intra, because inside. So that means the force now between sodium and chlorine is very strong. And it is greater, the difference between them, between the electronegativity is greater than 1.7. So that means in this case, it is what? Ionic. Okay, keep that in mind. If the difference of electronegativity is greater than 1.7, so in this case, it is what? Ionic bond. Okay, what about if we are talking about hydrogen and oxygen? When they make H2O, what will be the difference here in electronegativity? That one is 2.2 and that one is 3.44. So if you subtract them, what will you get the difference? It's going to be about 1.24. The difference is going to be 1 0.24, run out that number. So in this case now, is it greater than 1.7? No. So that means H2O, it's gonna be just equal to 1.7. That means it's less than what? Than 1.7. So that means if it is, which is here, H2O, if it is less than 1.7 and greater than 0.4, as you see here, it's going to be the difference between hydrogen and oxygen electronegativity you are talking about. In this case, you classify it as polar covalent bond. Again, if the difference between electronegativity is greater than 1.7, that means it's a strong intramolecular force. As we said, the strongest intramolecular force is ionic. So it's related to the difference between electronegativity. When there is a huge difference between electronegativity, that means the attraction between the components is very strong. When there is higher difference, strong, that means ionic. Okay, if it is not that difference, it's just between 1.7 and 0.4. In this case, it's going to be strong. It's still strong, but not like ionic. It's going to be called what? Polar covalent bond. Okay, what about if it is just less than 0.4? If it is less than 0.4, if it is less than 0.4, like 0.2 or 0.2, it is called covalent, but we cannot classify it polar or non-polar. If it is between 0 and 0.4, we classify it just as what? As polar. Okay, what about if it is 0? If the difference is 0, can the difference be 0? Yes. Hydrogen and hydrogen. What's the difference between electronegativity here? Hydrogen and hydrogen, the difference between them is 0. So in this case, if the difference in electronegativity is 0, we classify this bond as non-polar covalent bond. Non-polar covalent bond. So you understand now exactly how important, by the way, bonds are in our life, and it is responsible, and it is the reason behind why these objects are are solid and why these ones are liquid, and it's the result as why H2O, why we see water as liquid at room temperature, because there is a strong hydrogen bond between them, so we see it as liquid. But other elements or other molecules that have the same molar mass, like water, we're going to see it gases, while for water we see it what? We see it liquid, because there is a strong hydrogen bond. So that means more attraction between the molecules. That means molecules will be closer, so we see it what? Liquid. I hope that is clear for bonds. If you understand this video is okay. If you don't, you can repeat it 2, 3, 4 times till you understand it. And if you didn't understand some basics, you need to understand why. For example, if you didn't understand the electron configuration or how electrons are around the atom, you go to the previous video, which is related to electronic configuration, and then you watch this one many times again. Thank you so much. See you.